All right. Today marks 73 days left of school. And this is our 73rd day. It's hard to believe we started off with 180 days and now we are down to 73 days. So I'm going to use this to apply and have some fun with math. I'm going to propose a question. And after I'm done asking the question, you can press pause, and on a piece of paper, you can solve it on your own, and then press play and see if you did it the same way or a different way than I did. So the question is, there are 73 days left of school. What percent of the school year have we already had? I'll repeat it if you need to jot these down. We have 73 days left of school. What percent of the school year have we already had? Okay, go ahead and press pause. Okay, if you have started, you are ready to see if you did something similar and you could have done it in a different way. I'd be interested if you did it in a different way. Take a picture of it and post it on our Google Classroom. So I know that the question was, there are 73 days left of school. I know there are 180 days of school total. And the question is, what percent did we already have? Now, I could make a fraction 73 out of 180 and find out what percent 73 is out of 180, and that would give me the percent of school that we have left. And then I could take that percent and subtract from 100, and that would give me, but I'm going to do it a different way today. I know that 73 days left of school is what we are looking forward, and the question was, what percent did we already have? What did we already have? This 73 represents how many do we have left? Well, if I have 180, I'm just going to subtract 73 from 180. And 73 minus 180 is 167, I do believe. 167. Now, the 167 is representing how many school days we have already had. Oh my goodness, can't spell. How many we've already had. So let's see if I can make a fraction here. 167 of days we've already had out of a school year that's cut up into 180 pieces. Now I have a fraction that the percent that I get will answer how many I've already had. Well, before we do any sort of solving, remember, we always estimate our solutions when we're dealing with fractions. Is it almost nothing? Is it almost a half? Or is it almost a whole? Well, I'm looking at this 167 over 180, and I know that half of 180 is 90. So looking at 167, is 167 closer to 90, or is it closer to 180? I would say it's closer to 180, clearly. So I would do estimate, or almost a whole. Now, I know 167 is a prime number. At least I think it's prime. Yeah, it's prime. And 180 is even. So I cannot simplify this fraction. Now, if you want to know, prove me right or wrong, you can divide this by our prime numbers, our toolbox. Divide by 2, divide by 3, divide by 5, divide by 7, divide by 11, and divide by 13 to see if 167 has a factor other than itself and 1. But I'm pretty sure it doesn't. But I've been wrong before. So knowing that I have 167 divided by, because remember, fraction, all fractions are division problems. I know I do this all the time, but I never want you to forget it. The fraction bar is the same line that's in a division. So you read it 167 divided by 180. So 167 divided by 180. This and this are congruent. They mean the exact same thing. Well, I can't put 180 into 167. And I'm talking, the question was, what percent? And per means out of and cent means 100. So that means I have to cut up this number into 100 pieces. And the way I do that is the decimal represents the difference between whole numbers to the left and partial numbers to the right. And the first place value means we're cutting it up into 10 pieces. And the second place value means we're cutting up into 100 pieces, or hundredths, or percent. And then my decimal point comes straight up because I want to make sure that my answer, all the numbers that I put in here, are congruent with the place values that they are meant to be in. And so that is done by our decimal point here. Now, I'm going to go ahead and solve. I know that 180 does not go into 1, it does not go into 16, and it does not go into 167. How many times is 100 or 1,670, because now I'm looking over top of the zero, 1,670, how many times does 180 go in there? Well, remember, I front end estimate. And when I front end estimate, I'm looking at the 1, the number next to it is a 5, so I'm going to estimate 1,670 rounds to almost 2,000. And 180 estimated, front end estimate, this is higher, 5 or higher, so this rounds to 200. Front end estimates to 200. And I like to divide both by zeros. That gives me a better number in my brain to work with, and I know that 2 goes into 20 10 times. Well, I can't put a 10 here, so I know, and plus 180 is just a bit below, so I think my good guess, I'm going to erase this so I have room. My good guess is 180 times 9 should be about there. That's 0, 72, and that's 1620. Oh, look at that. Look. Now, this is one of those examples that a lot of kids, when they have this division problem, what they do, they see this big number right here, and they hate it because they multiply 180 times 1 and get an answer. Then 180 times 2 and get an answer. 3, 4, 5, 6, 7, 8. And then, look, it's 9. You would have sat there for 10,000 million years multiplying 180 times 1, 2, 3, 4, 5, 6, 7, 8 until you finally got to 9. Do you see how front-end estimating really can get you and save you a lot of time that gets you very close to the mark? Every time I've done it, it's been right there. Well, this time it was at a 10, so we knew that we could just go a little bit lower. So please make sure that when you're dividing with multiple digit divisors, you estimate, and it will save you a ton of time. So now let's subtract. We have 0 and we have 5, and we bring down the 0 here. Now, how many times does 180 go into 500? Well, look, I don't need to simplify this because it's already 500, and 200 goes into 500. Cut off my zeros. 2 goes into 5 2 times. So that's going to be my guess, my estimation, 180 times 2, 360. Well, could have I added one more? No, that would have been 540. So it is a 2. So I know right here that this is a 9. And that's how I got this 61620. And then we have a 2. And that is 360. So this tells me that we have 0.92 we have already had. So the original question was, if we have 74 days left of school and there are 100 days in a whole school year, what percent of the school year did we already have? And the answer would be 92%, because when we convert this decimal to a percent, we move the decimal point over 2 space and it becomes 92%. Now remember our initial estimation, we said it was going to be almost 1. Is 92% almost 1? Indeed it is. I hope you're getting good at this and enjoying it. Like I asked you yesterday, find something in your house where you have a part of a whole and make a fraction where the whole, what the whole's been cut up into is the denominator, and find out what percent it is. Estimate your solution. Do everything we do here, and the more you do it, the better you will get.